Welcome to Surds Level 6, one step in a level by level practice course. Pause the video now, try the problems on the screen, and I'll go through them with you shortly. At the end of the video, you can use the end screen to either practice more at this level or move on to a different topic, and you can find topic by topic playlists on the channel homepage. In problem 1, we're asked to show that this expression can be expressed as an integer. Now to start, rather than combining the fractions together straight away, it's going to be easier to rationalise and simplify each of them independently and then combine them after. So looking at the first fraction, we can start by expanding the bracket that's in the numerator. So we have 3 multiplied by root 11 gives us 3 root 11, and 3 multiplied by 2 gives us plus 6. And our denominator is still root 11 minus 3. And we can now rationalise, and we rationalise by multiplying the top and bottom of this fraction by the conjugate of root 11 minus 3, which is root 11 plus 3. And we do exactly the same on the numerator, making sure that we put everything in brackets so that we can expand accurately. And if you'd like a bit more help with expanding brackets in general, take a look in the top right corner where you can see my course on expanding brackets. Now back to the problem, starting with the numerator, we can multiply together 3 root 11 and root 11. This gives us 3 multiplied by root 11 times root 11 is just 11, so we have 3 times 11. 3 root 11 multiplied by 3 gives us plus 9 root 11. Next we have 6 times root 11, which is plus 6 root 11. And finally 6 times 3 gives us plus 18. Now moving our attention onto the denominator, we can start by multiplying together root 11 and root 11, which just gives us 11. Root 11 times 3 gives us plus 3 root 11. Minus 3 times root 11 is minus 3 root 11, and minus 3 times 3 is minus 9. Now looking at the numerator, we can simplify. So starting with the numbers that we have at the top, we have 3 times 11, which is 33, and we're going to add 18 to 33, which gives us 51. This becomes 51. We have 9 root 11 plus 6 root 11, which gives us plus 15 root 11. Moving on to the denominator, the 3 root 11 and the minus 3 root 11 are going to cancel out as expected. So we're just left with 11 minus 9, which is 2. Now since 51 and 15 can't be divided by 2, this is simplified and is equivalent to our first fraction. If we now focus on the second fraction, we're going to do something similar. So to start, I'm going to expand the denominator of this fraction. So 2 times 2 root 11 is 4 root 11, and 2 times 1 gives us plus 2. And the numerator is still 373 plus 101 root 11. Now to rationalise this, we need to times top and bottom again by the conjugate of 4 root 11 plus 2, which is 4 root 11 minus 2. You can write exactly the same on the top, and again, just ensure that everything goes into brackets. So if we expand the numerator, we have 373 multiplied by 4 root 11, and this gives us 1492 root 11. Next we have 373 multiplied by minus 2, and this gives us minus 746. Next we have 101 root 11 times 4 root 11. Well, 101 times 4 is 404, and root 11 times root 11 is just 11, so we get 404 times 11. And finally 101 root 11 multiplied by minus 2 gives us minus 202 root 11. In the denominator, we can also expand. So we have 4 root 11 times 4 root 11, or 4 times 4 is 16, and root 11 times root 11 is just 11. So we get 16 times 11. 4 root 11 times minus 2 is minus 8 root 11. 2 times 4 root 11 is plus 8 root 11. And finally, 2 times minus 2 is minus 4. We can now simplify the numerator. So we have 1492 root 11 minus 202 root 11, and this gives us 1290 root 11. We have a minus 746, and 404 multiplied by 11 gives us plus 4444. In the denominator, we can also simplify because the minus 8 root 11 and the plus 8 root 11 cancel out as expected. 16 times 11 is 176, and if we take away 4 from that, we get 172. So our denominator is just 172. Continuing with our simplifying of the numerator, we have 1290 root 11, and minus 746 plus 4,444 gives us plus 3,698, and our denominator is still 172. And they have several common factors. I'm going to jump ahead a little bit and just say that everything can be divided here by 86. So if we divide 1,290 by 86, we get 15. So we have 15 root 11. 3,698 divided by 86 gives us plus 43. And 172 divided by 86 gives us 2. So our second fraction is equivalent to 15 root 11 plus 43 all over 2. So going back to the original problem, we can now replace each of our fractions with our simplified versions. So we have 51 plus 15 root 11 all over 2 minus 15 root 11 plus 43 all over 2. Now these already have a common denominator, so we can just subtract them straight away. So looking at the numerators, we have 51 plus 15 root 11. And because we're subtracting the whole of that second fraction, we need to make sure that we put this in brackets. So minus, and then in brackets, 15 root 11 plus 43. And this is all over 2. Now the minus in front of that bracket on the numerator is equivalent to having a minus 1 there. So we can put a minus 1 there and expand the bracket. So we have 51 plus 15 root 11. Minus 1 times 15 root 11 is minus 15 root 11. And minus 1 times 43 is minus 43. And we still have a divide by 2 at the bottom. Now looking at that numerator, we can simplify further. So the 15 root 11 and the minus 15 root 11 cancel out. The 51 minus 43 gives us 8. So our fraction now becomes 8 over 2. And 8 divided by 2 just gives us 4. And 4 is an integer which we were expecting and is our final answer to problem 1. In problem 2, we're given a triangle where we're told that the base is 2 root 7 meters and that the area is 7 minus root 7 meters squared. And we're asked to show that h, the height of the triangle, is root 7 minus 1 meters. Now to start, we need to write down the formula for the area of a triangle. And the area of a triangle can be given as half times the base times the perpendicular height. I'm just going to write the perpendicular height as the height. And we can substitute in all the values that we know. So we're given the area, that's 7 minus root 7. We have a half multiplied by the base, and the base is 2 root 7, multiplied by the height, which is just h. So we can simplify the right hand side slightly. So the left is still just 7 minus root 7, and on the right, a half of 2 root 7 is just 1 root 7, or just root 7. So the right hand side just becomes root 7 h. We could write it as h root 7, either is fine. Now to find the height, we need to solve this equation, and we can solve by removing the root 7 from in front of the h, and we can do that by dividing both sides by root 7. And on the left, this gives us 7 minus root 7 divided by root 7, and on the right, we're just left with h. Now, although we have found the height here, it's not in the form that's required. And what we need to do to get this in the form that's required is rationalize it. So to rationalize this fraction, we can multiply the top and bottom by root 7. And when we multiply the top by root 7, we just have to make sure that we put this into brackets. So multiplying, we have 7 times root 7, which is just 7 root 7, and then minus root 7 times root 7 gives us minus 7. In our denominator, root 7 multiplied by root 7 is just 7. Now we can see here that both terms in the numerator can be divided by 7. So 7 root 7 divided by 7 just gives us root 7, and minus 7 divided by 7 is minus 1. And this gives us exactly what we're asked to get to in the question, which is that the height is equal to root 7 minus 1 meters. And that's the end of problem 2. In problem 3, we're asked to show that this expression can be expressed in the form a plus b root 11, where a and b are constants to be found. Now we could start by combining these two fractions straight away, but it's going to be easier if we can rationalize and simplify them before adding them together and trying to get them in the required form. So starting with the first fraction, we need to rationalize, and we can do this by multiplying together the top and bottom by the conjugate of root 11 minus 1, which is root 11 plus 1. Just need to make sure that these go into brackets so that we're now ready to multiply. So starting with the numerator, we have 2 times root 11, which is 2 root 11, and then 2 times 1 gives us plus 2. In our denominator, we have root 11 times root 11, which is 11, root 11 times 1, which is plus root 11, minus 1 times root 11 is minus root 11, and minus 1 times 1 is minus 1. Now our numerator can't be simplified at the moment, so this remains as 2 root 11 plus 2. Our denominator can, because plus root 11 and minus root 11 cancel out as expected, and we're just left with 11 minus 1, which is 10. And we can simplify one step further here because we can divide everything here top and bottom by 2. So 2 root 11 divided by 2 is root 11, plus 2 divided by 2 is plus 1, and 10 divided by 2 is 5. So our first fraction is equivalent to root 11 plus 1 over 5. Moving on to the second fraction, we can also rationalise this, and we can do this by multiplying by the conjugate of 3 root 11 plus 2, and that's 3 root 11 minus 2, which again we're going to do to the top and bottom of the fraction, and just make sure that any necessary parts are in brackets. So starting with the numerator, 1 times 3 root 11 minus 2 is just going to give us 3 root 11 minus 2, because multiplying anything by 1 doesn't change it at all. In the denominator, we can start by multiplying 3 root 11 by 3 root 11. Well, 3 times 3 is 9, and root 11 times root 11 is 11, so we get 9 times 11. 3 root 11 times minus 2 is minus 6 root 11. 2 times 3 root 11 is plus 6 root 11. And finally, 2 times minus 2 is minus 4. Our numerator here can't be simplified at the moment, so we just have 3 root 11 minus 2. And in the denominator, again, and as expected, the minus 6 root 11 and the plus 6 root 11 cancel out because we're rationalising, so expect those surds to disappear. And we're left with 9 times 11 minus 4. Well, 9 times 11 is 99, minus 4 gives us 95. And here, there are no common factors that 3, 2 and 95 have, apart from 1, so we can't simplify any further. And 3 root 11 minus 2 over 95 is equivalent to our second fraction. So going back to the original question now, we can replace each of the two fractions with our simplified versions. So we have root 11 plus 1 all over 5, and that's being added to 3 root 11 minus 2 all over 95. Now we can only add two fractions together if we have common denominators, and we don't at the moment. Having said that, if we multiply the first fraction on the top and the bottom by 19, the denominator will become 95 because 19 times 5 is 95. So we can do that. So our first fraction becomes 19, and then in brackets, root 11 plus 1. The denominator becomes 95 because 19 times 5 is 95. And our second fraction can just stay the same. So now that we have common denominators, we can just add the two numerators together. And I'm going to do this at the same time as expanding that first bracket. So 19 times root 11 is 19 root 11, and 19 times 1 is plus 19. From our second fraction, we also have plus 3 root 11 and a minus 2, and the denominator remains as 95. We can now simplify the numerator. So 19 root 11 plus 3 root 11 gives us 22 root 11. 19 minus 2 gives us plus 17. Our denominator still remains as 95. Now we can't simplify this fraction any further, but what we can do is write it in the form that's required. We can do this by dividing each term at the top by 95. I'm going to start with a constant, which is 17, because this is how they have it written in the question. So 17 over 95 can just be written as 17 over 95, and it can't be simplified anymore. And then 22 root 11 over 95 can be written as plus 22 over 95 root 11. So we now have it in the required form where A is 17 over 95 and B is 22 over 95. So 17 over 95 plus 22 over 95 root 11 is our final answer to problem 3.